Hello friends, in today's video we are going to discuss carbon dioxide transport. So let's get started. First, here are some facts about carbon dioxide. It has a molecular weight of 44. It has a boiling point of minus 79 degrees Celsius. And it has a critical temperature of 31 degrees Celsius. Critical temperature is the temperature above which a gas cannot exist in liquid state. So for carbon dioxide it is 31 degrees Celsius. The body contains a total of 120 liters of carbon dioxide. The partial pressure of carbon dioxide in arterial blood is 5.3 kilopascals, and in alveoli also it is 5.3 kilopascals. In venous blood it is 6.1 kilopascals. The CO2 production in our body is approximately 200 ml per minute under resting conditions. Now we will discuss CO2 transport. CO2 is transported in blood in three forms. 5% is transported as in dissolved form. 5% is transported as carbamino compounds. These are bound with the NH2 groups on hemoglobin, and 90% of CO2 is transported as bicarbonate. Now we will see through this diagram how CO2 is transported through bicarbonate. Now for transporting of CO2 as bicarbonate, there is an involvement of an enzyme carbonic anhydrase. Carbonic anhydrase combines CO2 and water to form H2CO3, which then dissociates into H plus and HCO3 minus. Now in this diagram you can see that as CO2 comes out of tissues, it moves into the red blood cells. Red blood cells have a high activity of carbonic anhydrase enzyme. So here CO2 combines with water to form H2CO3. This H2CO3 then dissociates into bicarbonate and H plus ions. This bicarbonate moves out of the red blood cell into the plasma, and hence CO2 is transported in this bicarbonate form. Now to balance the charge lost by the bicarbonate, chloride ions move into the red blood cells, and this process is known as chloride shift or Hamburger shift. Now we will discuss Haldane effect. Haldane effect states that deoxyhemoglobin has a high affinity for CO2 as compared to oxygenated hemoglobin. And you can see in this diagram that as the oxygen saturation of hemoglobin increases, it leads to a decreased affinity of hemoglobin for CO2. You can see that for the same partial pressure of CO2, the amount of CO2 bound to hemoglobin is less when hemoglobin is 100% saturated as compared to when it is 0% saturated. That's all for this video. If you have any doubts, you can ask me in the comments. Thank you.